be learning all about the key characteristics of a sine function. So, starting off strong, let's get to know a sine function. A sine function is an odd function by nature, meaning that it has a point of symmetry about the origin, and it can be represented by the equation negative sine of x is equal to sine of negative x. Sine functions are periodic, meaning that it repeats at certain intervals, and in this case, it repeats every 2 pi units. Graph behavior-wise, sine functions are smooth, and they're oscillating functions, and they oscillate between its lower bound of -1 and its upper bound of +1, and of course that means that it has a midline at y equals 0. Its domain is all real numbers, its range is from -1 to +1 inclusive, and it has an amplitude of 1. But let's actually see a sine function. Okay, so starting with the basics. A sine function is a fundamental trig identity represented by sine of theta is equal to opposite over hypotenuse. Now let's see how this can be translated to the terms of a unit circle. So in a unit circle or polar model, sine of any angle is equal to y over the radius, which in this case is 1. So if we start at the positive x-axis and move counterclockwise by any specified angle, the y-coordinate of the new ordered pairs that we'll get is the sine function. But now we can finally see a sine function in its graphical model. The graph of a sine function is a very smooth one, oscillating between its range, -1 to +1 inclusive. Its domain is all real numbers. Believe it or not, though, it does not exhibit asymptotic behavior, but rather has boundedness. What does this remind you of? That's right, a sine function. A sine function can be modeled by waves of any kind, in this case, tidal or water waves. And last but not least, sine functions are periodic in nature, so they're great for modeling anything with cycle-like behavior. Sine functions are for everyone if you think about it. So if you're a person that likes nature, sine functions are excellent in modeling seasonal changes, so anything from sunlight intensity to temperature to daylight hours, daylight savings. Sine functions are excellent at modeling this because they fluctuate at a predictable or almost constant rate. If you like business, economics, sine functions are great at modeling economic data, sales revenue, demand, things like that. They're greatly modeled by sine functions. If you like music, sine functions are great at modeling harmonic motion. So let's take a pendulum. The way it swings back and forth is modeled by a sine function. And to all the scientists and doctors out there, sine functions are great for modeling biological processes such as biorhythms and heart rates and whatnot. So don't forget that.